Assalamualaikum and good day. Welcome to CMA422. We're going to learn about a reinforced concrete design for beam. First, I need to explain a little bit about what is a reinforced concrete and what we will learn throughout the chapter of reinforced concrete design. It says that concrete is arguably the most important building material playing a part in building structure. Nowadays, macam dekat Malaysia ni, mostly whatever we build is built based with the material of concrete. This is the materials yang paling banyak lah dipakai dekat Malaysia because of basically here it is cheap, it is durable and it have a lot of desirable properties compared to macam katakan timber Kalau dekat Malaysia ni is a bit expensive, okay. Its virtue is versatility. For example, its ability to be molded to take up shape required for the various structure form. So you buat je lah mold jenis macam mana, however shape that you want, you can have it using a concrete. It is very durable and fire resistant when specification and construction procedures are correct. Concrete can be used for all standard buildings, both single story and multi-story, and for containment and retaining structures and bridges. Okay, not only limited to building, it also boleh buat retaining structure, bridges dan lain-lain. This is typical RC frame building. So the complete building structure can be broken down into the following elements. So first elements here is beam. Okay, so beam is horizontal member carrying lateral loads. Ini adalah beam, horizontal member. Horizontal is melintang. And then we have a column, vertical member carrying primarily axial load but generally subjected to axial load and moment. So column is this one, okay, yang menegak ni. So dia akan support axial load, probably coming from the roof. Okay, transfer to this load, and then the load coming from the second floor also akan transfer pada kolom yang dekat tempat yang sama tu lah. Okay, so dia akan berterusan sampai bawah and lastly it will transfer to footing. Slab horizontal plate elements carrying a lateral load. Slab yang the one yang dekat bawah ni lah, warna hijau, orange or yellow. Slab ni is okay, dia actually mostly dia akan transfer live load ataupun impose load lah, which is orang ke, perabot ke, benda-benda yang movable things yang perhaps duduk atas dia okay, ataupun mungkin kalau dead load yang slab support sekalipun, dead load tu is the finishes of the slab tu sendiri. Contohnya you ada tiling or you ada hardwood floor. So itu dikira sebagai dead load untuk slab And then we have a wall, vertical plate elements resisting a vertical, lateral and in plane loads. So should be wall, should be dinding tu lah. Normally concrete wall. So normally kita akan biasa pakai brick wall brick wall yang kita akan plaster later on. But it can also be a reinforced concrete wall. It is part of load-bearing wall. And then here we have bases and foundation. Bases and foundation ni, as you know, we have deep foundation and also shallow foundation. Okay, but mostly for reinforced concrete, kita biasa buat bed ataupun street footing macam tu lah. Okay, supported directly on the ground and spread the loads from column or wall so that they can be supported by the ground without excessive settlement. Alternatively, the bases may be supported on piles. So mungkin you akan buat bed footing, at the same time kat bawah tu pun boleh ada piling. So next here, so reinforced concrete is a composite material of steel embedded in hardened concrete matrix. Nama dia pun dah reinforced concrete. So is a combination of two materials. Composite lah sebab dia ada combination which are steel bar and also concrete. Concrete assisted by steel carries the compressive force, which still resists tensile forces. So concrete is highly recommended to resist compressive force, and also steel akan resist tensile force. So bila dia digabungkan, so it become a very high strength materials lah. Water is added and this react with the cement which harden and binds the aggregate into the concrete matrix, and concrete matrix stick or bond onto the reinforced bar. Kalau you tengok dekat this left side here, so this is like a elevation view, detailed elevation view for beam, column, and we have a foundation here. Okay, here we have L-shaped beam and a beam. So this is a continuous beam, continuous structure, sebab dia bersambung-sambung dan bersambung-sambung lah. So that's why dia ada macam ni. So this is a cross section of beam. This is cross section. You cut the beam, you see this is what inside. Okay, so you nampak sini ada titik 2 ni. This is bar 1, 2, 3 bar also, and there is a link. Ini kita panggil link. A small yang berpusing around this beam. This is, okay, nampak ni ada warna biru tu. So that one is the link. Kita panggil dia link. So dia yang akan ikat you punya bar tu. So barulah bar ni akan like connected by the link. And here we also have, this one is column. So column is a cross section coming from top lah. So you potong dia, you akan nampak inilah daripada atas. Sama juga around here, this is link and 4 bars. Okay, it depends on our design lah. Not only limited to this kind of cross section. Okay, and then here we also have slab. So kat sini this is a continuous slab. So dia bersambung because you nampak kat sini ada beam and also ada beam and dia bersambung together. So this is continuous slab. So slab is different daripada beam dari segi the layout of the, sorry, how you going to put the bar. Sebab bar dia ada bar arah yang cross each other macam ni lah, for example. So you akan placing bar mungkin macam ni, and then you akan letak bar macam ni. Okay, ataupun you pakai BRC. Okay, so dia akan jadi macam mesh. So ini yang sebenarnya you nampak dekat bawah ni. So this one is one bar yang macam panjang, and the other bar is melintang. Okay, so you nampak, so one dia panjang and another one is like titik. So rupa dia macam ni lah sebenarnya. Dekat atas ni also ada benda yang sama. Okay, but it always depends on the design. Okay, macam mana whether you need it or not. But normally you need it bila you ada buat continuous slab. And here we have wall. So wall, ini contohnya ini adalah column. Here also we have a column base. This is column. Okay, nampak ini adalah column. Okay, and also we have anchorage. Ni besi yang kat sini ni kita panggil anchorage. And here we have the base, the foundation dia lah. Reinforcement bar dia sama juga, style of reinforcement bar dia akan buat macam wire mesh macam ni So this is the one yang below, and you have the one at the longitudinal and latitudinal bar yang you akan letak dia macam ni lah. So I'm not going to explain too much on that. We're going to the next slide, which is cement. So cement I cerita sikit lah. Here we have the ordinary Portland cement. OPC is common type used. The raw material from which it is made from lime, silica, aluminium and iron oxide. When water is added to cement, the constituent are mixed from the construction are mixed to form cement paste. Chemical reaction occur and the mix becomes stiffer with time set. Many other type cement. Contohnya we have here rapid hardening Portland cement, low heat Portland cement, and sulfate resisting Portland cement. Rapid hardening Portland cement ni mostly we use this when you need formworks cepat. So sebab you nak pakai formwork tu, mungkin you pakai steel formworks. Steel formwork quite expensive. Steel mold lah kita panggil lah. We're going to use rapid hardening Portland cement so that dia punya hardening tu will become quite quick, lebih quicker compared to the normal OPC. And low heat Portland cement, normally when kita cast something yang very thick, that kita nak keep all the reaction rate of macam reaction, maksudnya heat generation dia, maksudnya dia nak mengeras tu sama. Okay, so low heat Portland cement, kalau you katakan you cast something yang very thick, very big, contohnya you nak buat foundation yang huge area of foundation yang thick, very thick, sebab bila dia kat bawah dengan kat atas, dia punya hardening kelajuan dia mengeras tu different atas dan bawah, sebab terlampau tebal so lain tau. It will affect nanti, for example kalau katakan atas harden dulu compared to bawah, the one yang below in a thick concrete, okay, so nanti dia akan ada serious cracking sebab dekat bawah tu lambat kering, atas lebih lambat keras, atas lebih keras dulu. Okay, so kita nak bagi dia sama, okay, so kita pakai low heat Portland cement. And then you also have here is sulfate resisting Portland cement, because normally this is used dekat area foundation. For example, kalau kita tak ada buat concrete blinding or something like that, to at least cover the area that we want to cast, we need this kind of concrete, basically to make the concrete sulfate resistance. Okay, sebab soil ni ada sulfate, so bila ada sulfate dia boleh serang cement lah. So bila dia serang cement, there is a chemical reaction happen going on, so it's not very good for the concrete punya condition. So we're going to need this kind of sulfate resisting Portland cement. Materials here we have aggregate. So kita dah belajar tadi cement, because ini yang ada dalam reinforced concrete. So the bulk aggregate is aggregate in form of sand and gravel which is bound together by cement. Aggregate is classes into, dia ada satu is coarse aggregate and one is fine aggregate. Okay, so you boleh baca, aggregate should be chemically inert, clean, hard and durable. Organic impurities can affect the hydration of cement and the bond between the cement and the aggregate. Aggregate juga kita kena make sure dia tak ada organic impurities. So, organic impurities ni contohnya macam vegetation terutamanya lah. So some aggregates contain silica may react with alkali in some cement, causing some larger aggregate to expand, which may lead to the concrete disintegrating. Aggregate ni ada silika, okay, tapi dia tak ada apa-apa, dia okey je. Tapi bila ada silika ni, dia bergabung dengan cement ni, dia akan react. Sebab ada air. Air ni is actually pemakin kepada any chemical reaction. So mungkin akan lead to expansion. Presence of chloride in aggregates, for example, salt in marine sand, will also cause corrosion in reinforcement. Excessive amount of sulfate will also cause concrete to disintegrate. Okay, so to obtain the dense strong concrete with minimum use of cement, the cement paste should be fill the voids in fine aggregate, which the fine aggregate and cement paste fill the void in the coarse aggregate. So that's why kita akan combinekan fine and coarse aggregate so that it will fill the void yang dibuat oleh coarse aggregate tu. This fine aggregate ni akan jadi macam bercampur-campur bersambung, dan dia akan jadi a very strong material lah. Okay, so coarse and fine aggregate are graded by sieve analysis, which the percentage of it passes offset of standard sieve is determined. We have concrete properties. Concrete properties, compressive strength. Kita ada beberapa concrete properties lah. First of all is compressive strength, and we have a tensile strength, we have a modulus elasticity, creep and shrinkage. So the compressive strength is the most important property of concrete. The characteristic strength that is the concrete grade is measured by 28 days cube strength. So macam mana you nak test the strength of the compressive strength of the concrete? You akan buat dia dalam bentuk cube lah. I believe that you dah buat this kind of cube, so dia akan ada a gauge yang akan measure lah how many loads that will cause the concrete to fail lah. And then here we have tensile strength. For tensile strength, so the tensile strength of concrete is about a tenth of compressive strength. So maksudnya 1/10 daripada compressive strength. So it means that compressive strength of concrete is much higher daripada tensile strength. That's why kita akan tambah reinforcement bar inside concrete untuk menghasilkan reinforced concrete so that it can resist both compressive and tension force. It is determined by loading a concrete cylinder across diameter. What you look at here dalam gambar ini, you see that this is a concrete cylinder. So concrete cylinder ni is not being put macam ni, dia tak duduk tegak. Okay, dia akan duduk menyengit macam ni lah, how we call it, baring lah. Okay, so it's going to be lay down, not vertically but horizontal lah. So kita anggap ni macam beam lah. So normally dia akan letak force from above. If you look at here, load. So also there is a supplementary steel bar. So you nampak kat sini ada steel bar so that the load distribution akan distribute throughout this area. You put load on top, so what will happen? This area akan berada dalam tension. Okay, so tension because of load dia nak separate. Okay, so dia akan in tension. So when in tension, when it reach the breaking point, so dia akan crack lah, pecah kat sini. This is on the tensile strength. Dia 1/10 daripada compressive strength. So we have a next properties, which is the modulus of elasticity. The short-term stress strain curve for concrete in compression as in figure. So as what I said before, Hooke's law, as what you have learned in part 1. Yang dibuat lah. So dia akan ada gauge yang measure the difference in length. Bila ada perubahan dari segi shape dia tu, the strain, kan still remember different in length divide by original length. And also the compressive stress. So the short-term stress strain curve for concrete in compression as figure. Benda yang sama lah, kita buat macam Hooke's law, but it's just that ini kita buat untuk concrete, so kita buat yang the compressive, yang kita pakai cube tu lah, that freaking cube. Okay, we put load and then kita letak kat atas dia load, and dia akan push this cube sampai the breaking point. Maksudnya cube bawah ni akan penyek, so dia akan dapat strain ni lah. Alright, so the slope of initial straight portion is initial tangent modulus. So this one kita panggil the initial tangent modulus. At any point P, the slope of the curve is a tangent modulus, is the tangent modulus, and the slope of lining joint P to the origin is the second modulus. So this one is second modulus, this one is, kita panggil dia, nama dia saja tangent modulus. So the value of second modulus depends on load and rate of application of, depends on the stress and rate application of load. So as you remember, kita punya stress, we know the formula is force divided by area. So the force that we put and the area that on top of this, so we're going to get the compressive stress. And from this value also kita akan dapat strain, and kita boleh buat the graph lah for the modulus of elasticity. So kat sini dah break lah. Okay, the performance going down. So there's not so much strain and there's not so much compressive strain you can put, and dia akan break. The fourth one is creep. Creep in concrete is a gradual increase in strain with time in the member subjected to prolonged stress. Okay, so if you put like stress yang lama, maksudnya the load is going to be in a very long time lah. So the creep strain is much larger than elastic strain on loading. So creep strain ni, apa beza elastic strain dengan if the specimen is unloaded, there is immediate elastic recovery and a slower recovery in strain due to creep. So kalau elastic strain, the recovery to the original shape akan lebih cepat. Okay, but creep, it is very slow. So kita panggil dia creep. Both amount of recovery are much less than the original strain under load. The main factor affecting creep strain are the concrete mix and strength. So the type of aggregate, curing, and relative humidity and magnitude, duration of sustained load. Dia depends on macam-macam factors. So antara factorsnya adalah ni lah. And lastly is shrinkage. So shrinkage or drying shrinkage is the contraction that occur in concrete when it dries and harden. Drying shrinkage is irreversible, but alternate wetting and drying cause expansion and contraction of concrete. So if let's say dia wet, dia basah, and dia kering, basah kering. So akan ada expansion dan mengecut dan mengembang konkrit. So the larger the size of aggregate is, the lower is the shrinkage of, and the higher the aggregate content, the lower the workability and water to cement ratio are. So that's why kita kena tahu actually the best possible ratio yang kita kena letak dalam konkrit. What it says here, makin besar size aggregate, makin kurang shrinkage. Okay, tapi higher aggregate content, kalau terlampau banyak aggregate, susah nak bekerja. And water to cement ratio, the lower water to cement ratio, the lower is the shrinkage. So kalau you letak banyak sangat water, dan dia akan lebih cepat untuk shrink. So aggregate that change volume on wetting and drying, such sandstone or basalt, give concrete a large shrinkage strain, while non-shrinkage aggregate such as granite or gravel give lower shrinkage. A decrease in the ambient relative humidity also increase shrinkage. So ada banyak factor juga yang affect shrinkage. So I'm going to stop here. So next we'll continue on the next video.